你好，感谢大家光临。我叫馬爪 Yuki. You. Thanks for gathering. I would like to give a presentation titled Issues and Solutions for Migration from MySQL PXC 5.7 to GR8.0 in Yahoo Japan. PXC means Percona Extra DB Cluster. GR means Group Replication. First, let me introduce myself. My name is Yuki Umazume from Japan. I work for LINE Yahoo Corporation. Since joining the company, I have been involved in the development and operation of MySQL for internal use as a database engineer. This is today's agenda. First, an overview of our company. Our company became LINE Yahoo Corporation in October 2023, when LINE and Yahoo Japan merged. The group now has over 320 million monthly users. It is used by a very large number of people. As you can see, our company operates many services in many fields. Yahoo Japan includes, for example, Yahoo Japan apps, left top apps, and Yahoo Shopping, Yahoo Mail, Yahoo Map, and so on. LINE Yahoo is composed of many users and services, so we have a huge amount of data. And we use multiple data platforms for different purposes. Even though LINE and Yahoo Japan have merged, but the platforms are not completely unified. I will now talk about the Yahoo Japan platform. Here is the data platform used in our company in Yahoo Japan. MySQL is an important platform that accounts for the majority of RDBs. We operate a large number of MySQL instances with 4,000 clusters of DBs and 12,000 nodes. Since 2010, we have been integrating and managing MySQL. DBAs manage MySQL on a common infrastructure. This presentation will focus on under multi-writer cluster. This is dbus. Now explain what is dbus. dbus means database as a service. We provide dbus, MySQL as a service platform. In dbus uses OpenStack and multi-writer MySQL. OpenStack is an OSS software platform for cloud computing. And for multi-writer MySQL, 5.7 uses the Percona Extra DB cluster provided by Percona. And 8.0 uses MySQL's original group replication. First, I talk about OpenStack. Simply, it is a set of software that allows we to create something like Amazon AWS. There are 4 main reasons why we choose to use it. First, it's extensive track record in our company. Second, it has management components for database. Third, ease of automation through APIs. Finally, configuration management by images. Next, I will talk the multi-writer MySQL. Similar terms are multi-master and dual master. In a multi-writer, these all nodes are sync with each other, and each master node can be written to at the same time. All nodes can be written to at the same time, so all nodes can be created with the same configuration. And the MySQL cluster structure can be as simple as tying the nodes to a load balancer. Also, if one node service out, it will be assigned to another live node that is still alive. At this time, there is still a session left. This service out node and change client. So there is no need to disconnect. No temporary disconnection, so maintenance can be performed non-stop. Service out one node and maintenance one node, only one node. And change service out node, only one node maintenance. This can be repeated and maintenance all nodes. Maintenance all nodes in non-stop. Next, let's look at MySQL with multi-writer. Rebus 5.7 uses Percona XRDB cluster. It's called PXC. PXC is a MySQL fork product called Percona Server with multi-writer. Therefore, before we developed Rebus, we have been using Percona Server. Percona Server has useful features such as detailed throw query logs and a query statistics function, and so on. Group replication has been available since 5.7.17. So when we were developing our first Rebus, it was not yet available. So we are comparing it to MySQL cluster and DB cluster and regular MySQL slave configurations. Other points of comparison are shown in the table here. This is also the reason InnoDB can be used and copy all the data needed for operation. As a result, we choice using PXC. Next, Rebus 8.0 uses group replication. Group replication allows vanilla MySQL to be used in a multi-writer. Vanilla MySQL 8.0 is catching up with Percona Server, useful features added in 8.0, such as the Chrome plugin. Also, we can use more standard configuration, making it easier to investigate and modify than when using Percona Server. Other points of comparison are shown in the table here. Group replication can do almost the same as PXC. As a result, we chose using group replication in 8.0. From this, I will talk upgrades and migrations which cannot be avoided when operating MySQL. According to the MySQL documentation, MySQL 5.7 is EOL. Vulnerabilities and bugs are not fixed, so we need to upgrade to MySQL 8.0. Same as normal maintenance, we want to minimize several service downtime. Migration of DBs using MySQL 5.7 to MySQL 8.0 will be performed with only downtime during the switchover. This is migration flow. First, create new DB with MySQL 8.0 and import data from current DB to new DB. And create replication from the current DB to the new DB. First, temporarily stop writing and stop replication and direct the connection to the new DB. This minimizes downtime and ensures a safe migration. Finally, delete old MySQL 5.7 DB. I'm writing verify, but there are some points to note. Here are some of the changes from PXC 5.7 to group replication 8.0. This is about the changes. The basic changes are summarized in the MySQL documentation. There are changes in syntax and variables. For example, if we are using ascending or descending order in group by, it is now necessary to add a separate order by. And there are many variables whose defaults have been changed, added, or removed. Some of reserved words have also been added or deleted. These changes may return errors if we are using the same SQL used in 5.7. Next, the changes from Percona Extra DB cluster to group replication. Basically, group replication can be handled under the same conditions as PXC. One change is that group replication now requires a primary key. A primary key is still required for PXC, but it can be created by setting the variable PXC strict mode to disable. And other configuration variables have changed, and some variables are only available in PXC, such as PXC strict mode or FT query extra word chars. From here, I will present some of the issues that during the migration and how they were resolved. I introduce these 3 points. First, foreign key bug in group replication 8.0. In group replication, in merge primary mode, which is merge writer mode, a bug exists. Update to a table with foreign keys. If the update is performed in more than one session, it returns an error that the write cannot be performed. This bug occurs with a probability of 10% to 25%. Insert two tables with foreign keys in one session, left side one session, this bug does not occur. However, sometimes an error is returned, right? Is for more than 2 sessions, error occurred. Since it does not fail completely, it can be avoided by including a retry process in the operation. However, it is occurred during replication. Replication will stop. We can run insert or update to PXC, and it doesn't error occur, but error occurs in a replication to group replication. This is because replication is multi-thread. The solution is single-thread replication. Sets several parallel workers to 0 in group replication. It is single-thread doing replication. And replication can continue without error. This changing setting is a trade-off for speed of data sync. So have clients switch connections at time of low load to avoid large delays when switching DB. Next, data comparison. It is necessary to check for current migration and consistency. This is the process to check if the migration has been done correctly. Step 1, stop DBs in the same state. But now, all DB cannot be stopped. So we compare by using data in the same state. In step 2, hash values for each schema and table are compared to see if they match. If they match, we have successfully migrated and will restart replication. Just now, I said we compare by using data in the same state. For this purpose, we use snapshot. Snapshot means store the state of the database at a specific point in time. Take a snapshot in session and keep the same state by executing queries in it. This is a concrete operation. First, do the following to the old DB. Set sessions, transaction isolation level, repeatable read. This session is not affected by other session by this command. Second, first transaction with consistent snapshot. It is we can take a snapshot in this session and see the same data at the point in time. Third, show status like winlog snapshot. We can get now data status. After that, operation do the following to the new DB. With the get it data, proceed to the same point in the destination group replication and start replica until source log file and source log position. After we can compare old and new DB with the same data. Data comparison step 2 is hash values for each schema and table are compared to see if they match. We run select hash from schema table, order by primary key. Sort by primary key to avoid using temporary disk space and get hash values. At the time, it is sometimes determined that the data has been replaced, even though it is correct. The cause was that when taking snapshot in the migrating PXC, they were sometimes out of position. In the commit step has 3 steps in PXC. First, flashing transaction to binary log. Second, syncing binary log file to disk. Finally, commit all transactions in order. In the three stage when commits in PXC, if a snapshot is getting at 2 to 3 points, when this error occurs. To resolve this problem, a record lock can be acquired when taking a snapshot to prevent position changes. Before get snapshot, flash tables with read lock, and after unlock table, this is release lock. After that, now we can compare correctly if we have successfully migrated. Finally, switch back. After migrating from 5.7 to 8.0, you may want to switch back to the 5.7. Performance degradation or SQL compatibility, application compatibility, and so on. This can be handled by replicating from the 8.0 to the 5.7 in the reverse direction in before of the switchover. And we talked about this in the previous session, so it's the same thing. If the write is done in MySQL 8.0 with the default character set, reverse replication will fail. The reason is MySQL 5.7 has not MySQL 8.0's default character set. It is UTF-8 MB4 0900 AICI. In the previous session, using init connect to work around this issue. In Yahoo Japan, dbus sets default correction for UTF-8 MB4 at cluster build time to manage default session to match. If a non-default character set is specified as the PXC 5.0, that character set is also made to match the default at the group replication 8.0. However, the super user doesn't enter these settings, so the same issues occur. Therefore, either relies the my.conf or the super user can work around this by executing set names and correct for PXC default setting at the beginning of the login. These are some of the issues that during the migration and how they were resolved. Finally, we have created a tool for migration to be used in Yahoo Japan. As mentioned in the introduction, we have a large number of MySQL instances in operation. It will like a lot of time and effort to migrate all of them to MySQL 8.0 by hand. So we developed a tool for the migration. Similar to the MUH we're talking about previous session, this is automated data migration and replication building and so on. This allows migration to be performed without a DBA. This concludes the presentation. And we are looking for a database management engineer in Taiwan. Please see our website for more information. It's over. Thank you for your attention. 谢谢。